Okay, in this video, like we did with the last one over a translation, we're we're not going to do a translation to make the equation nicer. In fact, we're going to start with a nice equation in the x prime y prime plane. You can see the ellipse drawn here. And so as a matter of fact, we'll just say, so the equation for this is, we'll just say x prime squared over 25 plus y prime squared over 9 equal to 1. That's very nice in the x prime y prime. The problem of it is, and I'm going to have to erase that and move it because I should have did this, so I'll put that back here in a second. The thing is I really, for whatever application I'm doing, I need the xy plane to be my reference. So I need an equation, same ellipse, but I need the equation in terms of x and y in the xy plane. Once again, so now I can write this. My ellipse here, very nice equation. My ellipse is simply in the x prime y prime is x prime squared over 25 plus y prime squared over 9 equal to 1. Okay, so now let's think about it. That means that the distance here, this is 5 from here out to this vertex from here. I'm lining these up so where this is my origin right here is 0, 0 in both the x prime y prime plane and in the xy plane. So we won't need to do a translation once we do this. So and of course this point out here, this point here, then in the xy plane is 4, 3. Just because I can make it that, because now I can create a nice 4, 3, 4, 5 triangle because of how I've made because of the ellipse I'm trying. It's a nice book example, so to speak. Now, as you recall, okay, as developed in the rotation notes addendum that you have in your set of notes, we developed these two equations to get us from an equation in the x prime y prime plane to an equation in the xy plane. So we have this substitution essentially of this set of transformations, these two equations. So what I need to find, what I'm looking for next is, okay, I need to find theta, or really in reality I don't need theta, I need cosine of theta, sine of theta. That's really all I need. I don't ever need to know what theta is. So we'll come back to our picture. Okay, so theta in the drawing at least is this, whatever this is. Okay, but what I do know is then that the distance is that this point here, as we said here, okay, is at 4, 3. So I'm going to come over here, I'm going to take, so I have a triangle here, okay, but I'm going to pull it out over here. Okay, so the hypotenuse is 5. The x coordinate is 4. So this side's 4. The y coordinate is 3, so this is 3. Again, this is theta, whatever it is. But like I said, I really don't need to know theta. I just need cosine and sine of theta. And from this, I know that cosine of theta is 4/5, and sine of theta is 3/5. Everything's positive. So yeah, positive 3, positive 4. Yeah, we're doing a nice example. So from there then, okay, I can now take and substitute this right here in for x prime, and I can substitute this in for y prime. And so, and I know cosine of theta is 4/5 and sine of theta is 3/5. So I'll have this set of equations now that I'm developing. Same ellipse, so it's equation for the same ellipse, but it's an equation that references the xy plane instead of the x prime y prime plane. So we'll have, and I'll just put it in the same, so I've got x times cosine of theta, that's 4/5, plus, so I'm replacing x prime with this, so plus y times sine of theta, so that's 3/5, all that squared over 25. Nothing changes there. Plus y prime gets replaced with this y cosine minus x sine, so that's going to be y times 4/5 minus x times 3/5 quantity squared over 9 equal 1. And so there's my equation. Same ellipse, but it's an equation in xy, so it references the xy plane, the position of my ellipse in the xy plane. And of course, you can do a little bit of work, and you all can do this. So this cleans up a little bit. Again, we weren't out to make a clean equation. We knew we were going to make an uglier one. So I'd end up with what? 4x plus 3y quantity squared over 625 plus 4y minus 3x quantity squared over 225 equal 1. Okay, so I got an uglier equation, but I needed an equation for the same ellipse that referenced the xy plane or the xy axis, and that's what I did. And that's pretty straightforward. Again, all that comes from those original notes. We just go in the other way.